Lewis Carroll's condensation method. This method was invented by Charles Dawson in the 1866, who is much better known by his pen name Lewis Carroll, under which he wrote Alice's Adventure in Wonderland and Through the Looking Glass. He also wrote several mathematics books and collection of logic puzzles. And here he described the method as a new and brief method for computing determinants, which he called condensation. Although it is not well known today and rendered obsolete by numerical methods for evaluating determinants, the condensation method is very useful for hand calculation. When calculators or computers are not available, students mostly rely on this method because it only requires the ability to compute a 2x2 determinants. Definition: if A is an n by n matrix with n greater or equal to 3, the entry of A is the n minus 2 by n minus 2 matrix obtained by deleting the first row, last row, first column, and last column of A. Here we will illustrate a 5 by 5 matrix using the condensation method of determinant A. So we begin by setting the A0 equal to the 6 by 6 matrix, all of whose entries are 1. Then we set A1 equal to A, the 5 by 5 matrix. And it is very helpful to imagine this as the method like a pyramid where the A0 as the base and the A1 on top of it. Then we're going to add successively smaller and smaller layers to the pyramid until we reach a 1 by 1 matrix at the top that contain determinant A. Next, we condense the A1, the 5 by 5 matrix, into a 4 by 4 matrix A prime 2, whose entries are determinants of all 2 by 2 submatrices of A1. So, and to compute the 2 by 2 submatrix, we use the formula A, B, C, D equals to A times D minus B times C. So this should be 2 multiplied by 2 is 4 minus 3, it is 1. This one is 9 plus 2 is 11. Negative 1 minus 6 is negative 7. This is negative 8 minus 0, it's still negative 8. 1 multiplied by negative 1 is negative 1, and then minus 4 is negative 5. This one, 2 times 2 is 4, plus 3 is 7. 3 times 1 is 3, minus 2 is 1, and here 1 plus 4 is 5 for the third row. 2 plus 3 is 5. Negative 1 times negative 1 is 1, minus 2, so it's negative 1. 2 times 2 is 4, plus 1 is 5. 1 times negative 2 is negative 2, and minus 2 is negative 4. For the last row, we have 3 multiplied by 1 is 3, minus negative 4, it's 7. 1 multiplied by 0 is 0, plus 1, negative 1, minus 2 is negative 1, and 2 plus 4 is 6. And after we get the A prime 2, which is the 4 by 4 matrix, we now need to divide each entry of the A prime 2 by the corresponding entry of the A0, interior A0, to get the matrix A2. But since like earlier we set the A0 all 1, so this means that A2 equal to A prime 2 divided by 1, so it's still the same. So A2 equal to A prime 2. And then we repeat the process by first we condense the 4 by 4 matrix into 3 by 3 matrix A prime 3, and where all of the entries are 2 by 2 submatrix. So like just like the previous, we use the same method. This is 7 plus 55, it's 62. 11 times 1 is 11. Times 49, it's 60. Negative 35. Plus 8 is negative 27. 5 minus 35 is negative 30. 35 plus 1 is 36. And this one is 4 minus this one is negative 29. And this is 5 multiplied by 1 is 5. Plus 7 is 12, and this is minus 4, and this is 26. And after we get the answer for the A prime 3, the 3 by 3 matrix, we then divided each entry of the A prime 3 by the entry of the interior A1. And in order to do it, we first delete its first column, first row, last row, and last column. And now we set the A3 equal to the entry of the A prime 3, which is 62 divided by 2, 60 divided by 3, and negative 27 divided by 1, and so on. And first answer is 31, 20, negative 27. And yeah, like that. Next is A prime 4, just like the previous again. We condense the 3 by 3 matrix into a 2 by 2 matrix, where the entries are the submatrix of 2 by 2 matrix. By using the same method once more, the answer, this one is 31 multiplied by 18 minus 30 multiplied by 20, so it's negative 42. 20 multiplied by negative 29 minus negative 27 times 18, so it's negative 94. And this one is negative 96. And the last is 350. After that, we try to find the answer for the A4 by dividing each entry of the A prime 4 by the entry of the interior A2. So just like the previous, we delete the first column, first row, last row, and last column. Now that A4 is equal to negative 42 divided by 7, that is negative 6. Negative 94 divided by 1, that's negative 94. And the second row, negative 97 divided by negative 1 is 96. and 350 divided by 5 is 70. Now that we got the answer for A4, we can once again condense the A4, the 2 by 2 matrix, into a 1 by 1 matrix A prime 5, and the method is the same. So now we can compute this using the 2 by 2 sub matrix. Negative 6 multiplied by 70, that's 400. Negative 420 and 120 and 96. 96 multiplied by negative 94 is 9024. So the answer is 8604. After that, we divided the entry of that A prime 5 by the entry of the A3. So by deleting all of the first row, first column, last row, and last column, A5 is equal to 8604 divided by 18 is equal to 478. And so so this is the one. So the answer is the 1 by 1 sub 1 by 1 matrix, and the answer for determinant A is 478. That's all for my presentation.